Hi guys, what is up, and welcome to Vertical Coding. In this video, I'm going to give you an introduction to waves in physics. So if you're new to this channel, please make sure that you do subscribe to my channel for more updates, for more information. Once you do subscribe, you'll be able to receive an automated notification to your YouTube that there's a video that you have uploaded. Okay, so now let's now dive into this topic. So first of all, we're going to look at the definition of what a wave is, and we'll also look at the types of waves, then also how to describe a wave, and then finally also look at the wave equation. Okay, so let's now dive into that. Okay, so now what we mean by that is a wave is a disturbance through a media. And now this common disturbance, normally we call it disturbance through a media, and this common media is normally, we can give an example of water. Okay, so that is the best and the closest example we can give when it comes to waves. Okay, so now what are some of the types of waves that we need to know? Okay, so the types of wave is we have a transverse wave. We also have what is called longitudinal wave. Okay. Okay, so now we have to define what is a transverse wave. Now, a transverse wave is a type of the wave in which the particles, okay, they move perpendicular to the direction of the wave motion. Okay, so you have to understand that in a transverse wave, the particles, they normally move, okay, perpendicular to the uh, to the to the direction of the wave. Okay. You look at when you're talking about a transverse wave. Okay, this is a wave in which the particles moves perpendicular to the direction of the wave motion. Okay, so what we mean by that is when you're looking at a transverse wave, the particles that causes the movement normally moves perpendicular to the direction of the wave motion. So if the direction of the wave motion is coming toward you, like just right now, okay, so the particles, they get to move like this, okay? So they normally move in that direction, okay? So that is the most important thing. So the particles move perpendicular to the direction of a wave motion, okay? And normally we can indicate a simple illustration like this. So where you have goes like that, goes like that, goes like that. Okay, so that's how the particle is normally moved. And from there now, the direction of this wave motion is in that direction, and now the vibrating particles, they move like that, they move like that. So at this point, okay, at this point, when they move, okay, at this point, so okay, so they move like that. So they move at right angles, okay. Now, what about now? What is an example of a transverse wave? Now, an example of a transverse wave is normally water that I mean waves that are coming or produced from the water waves. Okay, so waves that are produced from the water source. That is a transverse wave. Okay, and now also let us look at the longitudinal wave, and we can also see the differences between this one and also the longitudinal wave. Okay, so now we are going to look at the other kind of the wave, which is a longitudinal wave. Okay, so let us stick to that. Okay, so now when we look at the other type of the wave, so when you look at longitudinal wave, the only difference between a longitudinal wave and also a transverse wave is that in the longitudinal wave, the particles that are normally generated within that wave, okay, they move parallel to the direction of the wave motion, okay. Okay, so when you look at a longitudinal wave, okay, this is a wave in which the particles, okay, the particles, they move parallel. So the key word is parallel. So it's actually moves parallel to the direction of the wave motion. Okay, so what is an example of this wave motion you're talking about? Okay, I mean this longitudinal wave. So longitudinal wave, e.g., so we have the best example is sound waves. Okay. Okay, so the best example that you can give is sound wave. So how does now a longitudinal wave looks like? Okay, so a longitudinal wave looks like let's say this, and okay, so it looks like okay. Now, what you need to understand when you talk about a longitudinal wave is that the direction of the wave, that is in which also the particles that causes that wave also moves in the same direction as where the wave direction is going, okay? So the waves, they don't move actually up and down, like perpendicular to the wave motion, but this one moves parallel. So now you can see that we have this part, okay? So this is, okay, so now in the longitudinal wave, we have within the wave kind of a structure, we have regions that are closely, where the particles, the air molecules are closely, concentrated, for example, or packed the particles. And then also we have a region where now the particles are like scattered. There is enough spaces there, the particles are far away from each other. So the region where the particles are closely together, and that is a region we call the region of compression. And then also we have a region where the particles are scattered, and that is a region of rarefaction. Okay, and we can see that is a region of compression. Then this is a region of rarefaction that is widely spaced. So that is the most important thing. Okay, and that is the difference between the transverse wave as well as the longitudinal wave. Okay, so make sure that we get the differences between them. Okay. Okay, so now let us look at how you can describe a wave. Okay, so a wave, we're going to actually use a transverse wave because it is more clear to use a transverse wave in order to describe like what is the wavelength, what is the amplitude, the frequency, as well as the speed of the wave, and so on. So let's dive into that. Okay. When you look at this wave, you have to describe this wave with some of the things that we must be able to, some of the terms that are used to describe the wave. So you can see we have the amplitude, we have the wavelength, and of course, we're putting some other stuff. Okay, so now, like I was saying, we have to define what is a wavelength, and then also we have to define what is an amplitude, as well as the speed of the wave, and then also we have to define what is a frequency of the wave. So let us define some of this. So when you're looking at the definition of what a wavelength is, then you're looking at the distance between a crest, and then the unit is meters. Okay, and because distance is measured so the distance is measured in meters, and the symbol is just this symbol. Okay, which is normally pronounced as lambda. Okay, so it is called lambda. Okay, and then also we have, okay, and then we have this is A, and then B. Okay, and then we have what is called frequency. Now, what is frequency? So frequency, this is the number. So this is the number. So the frequency is simply the number of complete waves generated per second. Okay, and the units is the hertz, or simply Hz. Okay. Now the symbol of the frequency is just this F. Okay, that is a symbol of the frequency, which is the V is just velocity. So now when you look at the speed of the wave, simply saying that this is the distance moved in the direction of the wave motion per second. Then we also have this, you see. Last one is the amplitude. So this is just the height of a crest, or the depth of the trough from its resting position. So the amplitude is the height of the crest or the depth of the trough from its resting position. So you can see like this, okay, this one up there to this point. So this is the height, the maximum height or the minimum. So from this initial 0 point, okay, so it can either be downward or even upward. So the height, okay, so the height. So even the units for this one is just the meters, okay. So the units of this one is just the meters. And then for the speed is just the meters per second. Okay. So the normal speed that we know from acceleration, velocity, meters per second, the amplitude, it is meters. Okay. So now let us finally look at the wave equation. So now finally we look at the wave equation, okay, or simply the formula for finding the speed of the wave. Okay, so there's some bit of some manipulation, some principles that you need to understand. Okay, so let us see how you can do that. Okay, so we know that speed equals to distance over time. Okay, and we also know that the frequency of the wave is 1 over t. Okay, and now this distance, the distance is normally the wavelength. So the distance is the wavelength, and we know that this wavelength has a symbol of lambda. Okay, so now this speed can also be substituted with velocity. Okay, so that is S equals to V. So now what is S? We're going to put V equals to distance, which is lambda, and over just t. Now from this one, we can make t the subject of the formula and then come and use that t and substitute it there. Okay, so this is F equals to 1 over t. Okay, this is now going to be t. Okay, t equals to 1 over F. Okay, and then now we are going to take this t and then substitute that and substitute this one here. Okay, so now we are going to say V equals to lambda over 1 over x. So now from there now, I'm going to say, simplify this now, is going to be V equals to this divide by 1 over f, okay? And then now V equals to lambda multiplied by f over 1, okay? And this V is just now finally, it's just going to be f dot lambda. Now this is equivalent to just V equals to this. Okay, so that is the wave equation. Okay, this is the wave equation, and that's all we need to know about introduction to waves. And this is part A. And make sure that you follow and understand some of the definitions, and then also the formula for finding the speed of the wave. And then in the next now session, you're going to look at the actual examples, either from the past paper or the general example, just to give you a more in-depth understanding of waves. So thank you so much for watching, and I'll see you in the next video. Thank you.